Angle of elevation, angle of depression. Okay, the one thing you have to remember about angle of elevation or angle of depression is that it always is measured from horizontal. So you start horizontal. If you go up, that's angle of elevation. Horizontal down is angle of depression. Okay, but you always start from horizontal. For some reason, that's hard for people to remember. But you have to always start from horizontal, then up is elevation, down is depression. Okay, so like here's the submarine, and the horizontal line is sea level, right? And then it goes up. The guy in the conning tower looks up at the sun, so the angle of elevation is right here, is A. Okay? And the reason we're learning about it right now is if I draw a line from the sun down, what did I just make? What kind of triangle? A right triangle, which is now our best friend, right? Because we have Pythagorean theorem, we have special right triangles, we have SOHCAHTOA, we have all kinds of stuff we can use to solve for pieces of right triangles. So that's angle of elevation. Angle of depression is, again, horizontal down. So the altitude of the plane is our horizontal line, right? If you go straight across, like if the pilot's sitting in the cockpit, his horizontals from his eyesight. So if you go down to the ground, that's the angle of depression. And again, we can draw a line, make a right triangle. But for, like I said, the hardest thing for kids to remember, angle of elevation is horizontal up, horizontal down is depression. For some reason, that messes people up. Okay? So we're going to be doing word problems that describe angles of elevation and depression. And for every single one, you've got to draw a picture. There's just no way to do it without drawing a picture. So for every word problem, you need to draw a picture. And we're going to do the two most famous ones, like the ones you'll see on all the standardized tests and all the textbooks. Every single one has a forest ranger problem in it. So let's do a forest ranger problem. Okay, it says a forest ranger is in a 90-foot observation tower. So here's my observation tower. Here's my ranger. Okay. And it's 90 feet above the ground. All right. And he sees a fire. So way out here, there's a fire. Okay. The angle of depression to the fire is 7 degrees. So angle of depression has to start from where? Horizontal. It starts from horizontal. So from the ranger, I'm going to make my horizontal line. Okay? And then the angle of depression is going to be to there. So going down 7 degrees. Okay? For some reason, people are tempted to make like the angle of depression right in there. I don't know why. But it's always from horizontal and then down. Right? And it says, what is the horizontal distance between the tower and the fire? Because if you were the ranger and you were up in this wooden tower, wouldn't you care how close the fire was? Right? Because you would burn you're 90 feet above the ground and you don't want to get burnt. All right, so they're looking for the distance, the horizontal distance to the fire. Okay? So here's my right triangle, right? Okay? And I'm looking for x. Okay, now there's several ways you can solve this problem. One is you could make it into a rectangle. because if this side, if it's a rectangle and this side's 90, what's this side? 90. And if it, 90. And if this is x, then this one is x. And now I have a different right triangle, okay? But it would give me the same answer. The other way you can do it is these two lines are parallel, right? So what do we call this line? A transversal. And what do we know about these two angles? They're equal because they're, oh, awesome, alternate interior, right. You guys are so smart. Right, alternate interior. So you could make that 7 degrees, and you could do your problem that way. And the third way to do it is, what do we know about this angle up here? Right, the whole thing is 90. So if this is 7, how much is this part, the green part? 83. So the other way you could do it is do it from the 83-degree angle. So 3 different ways, they'll all give you the same answer. Okay, so now we do just like we've been doing yesterday and the day before and the day before that maybe. We figure out what two sides we're dealing with. We pick a trig function based on that, and then we solve the equation. So what two sides do I have? Opposite and adjacent, right? So opposite and adjacent use tangent. So I could do the tangent of 7 degrees, and that's opposite over adjacent, so that'd be 90 over x. Or I could do the tangent of 83 degrees, and that would be opposite over adjacent, so that'd be x over 90. Either one's going to give me the same answer, so I'm good. All right. The problem with this one is the x is on the bottom. How do I get the x out of the bottom of the fraction? Right, multiply both sides by x. That gets round to the nearest foot. Yep. So I get 90 equals, what's tangent of 7? So I have 0.1228x equals 90. Divide by 0.1228. 0.1228. And that gives me, what's 90 divided by 0.1228? 732.8, so 733. Okay? All right, or I could just take tangent of 73 times 90, so multiply both sides by 90. What is tangent of 83? Can someone type that in? 8 point, I just messed it up. 8.144, give me one more decimal. 1443. Okay. And then multiply that by 90, and I get 733. 732.8. Yeah, 733. So it doesn't really matter which one I do. I end up with the same problem, same answer. Okay? So far, so good? All right. The other kind of famous one is the FAA problem, and this is actually something when we sold like a $3 billion contract to the FAA to upgrade all their air traffic control towers, and this is actually something we had to like code in, because do you remember that problem on your homework about the boat being 2 degrees off? Remember it was said like here's the ship and here's the island, and they were 2 degrees off. How far were they away from the island? Like how far did they get off course? And this was like 30 miles almost, right? Something like that, 20 some miles. So even a tiny, even at 24, thank you, even a tiny bit off makes you really off. So if an airplane is like a tiny degree off, they're landing in a field instead of the airport. So it's important that you are very accurate when they're, so they calculate this constantly, like in the programs we wrote, it calculated that trajectory all the time, like constantly, to make sure they were still on track. All right, so anyway, that was neither here nor there. An air traffic controller at an airport sights a plane at an angle of elevation of 41 degrees. So here's my air traffic controller, okay? And he sees an airplane up here. You can tell I worked for FAA because I had draw airplanes so well. So there's my airplane, and he sees my airplane, or sees the airplane, but to do an angle of elevation, I have to start at horizontal. So here's the horizontal, okay? So it goes up from horizontal because it's an angle of elevation, and it's 41 degrees according to the problem, okay? The pilot reports the plane's altitude is 4,000 feet. So where would that go? Right, up and down. It'd be vertical, right? He's 4,000 feet in the air. What is the horizontal distance between the plane and the airport? So the plane is this far away now. We're looking for how far it has left to go. Okay, so I'm going to mark that X. What trig function am I going to use? Tangent, right? So I'm going to use the tangent of 41 equals opposite over adjacent. Now, if it, instead of asking how far the plane, the horizontal distance from the plane to the thing, what if I said, what's the distance between the air traffic controller and the plane? What part would you find? The hypotenuse, right? Okay? We can't solve for x in the bottom of the fraction, so unfortunately, got to get rid of it first. So I move it over to the other side, and that gives me x times, what is the tangent of 41? 886? Okay. Equals 4,000. Okay, divide by 0.8693, and I get 600. I don't think so. Yeah, isn't it 1 point? Is it 1.4 or 1.9? 0.40, so it's 1. Yeah. Yeah. Try that. Type it in again, Manira. That's. Did you get 4601 this time? Did you get it? Okay. All right. So did you expect when we divided by 0.8693, do you expect that number to be more than 4,000? Yeah, when you think about it, if x were 1, how many times does 1 go into 4,000? 4,000 times. So if this number is less than 1, won't it go in more than 4,000 times? So we're expecting this number to be larger than 4,000. Does that make sense? Okay. Okay. All right, questions?